science class. Today we are going to start the 13th lesson in your textbook, that is fun with magnets. Okay, you all know what is magnet. Nowadays everywhere you can see the presence of magnet. In the refrigerator door, the magnetic doors, in the vehicles, everywhere you can see the magnet, right? Yes. Did you ever think that where is the origin of this magnet and who invented this magnet? Dear children, there is an interesting story regarding the invention of magnet. In the village of Greece, there is a boy who is a shepherd, always carrying his goats in a mountain region. Every day that boy, whose name is Magnus, he used to carry all the sheep into mountains, and he also carried a stick along with him. One day, what happens, unfortunately his stick got stuck into a rock. Children, at the tip of the stick there was iron rod was there, iron round was there at the tip of the stick. And suddenly it got stuck into the rock. And he will be wondering that what is this. And he is trying to pull on this, and the very next moment it will be again stuck on the rock. And the people wondered that what is it. And finally they invented that was magnet. Okay, so the iron stick, okay, that will be stuck on the magnet. Okay, so children, in order to honor him, okay, the name of the magnet that was invented, that is the natural magnet. That natural magnet is known as magnetite. Do you know from where the name magnetite come? Yes, that boy's name is Magnus. Okay, that is why they have given the name as magnetite. So magnetite is the naturally invented magnet. Okay, magnets attracts all type of objects. Yes, you can see here the types of objects. Some are made up of plastic, some are made up of glass, and some are made up of leather. And here you can see the common examples of metals. Okay, what are the metals? You can see iron, nail, and you can see needle. Okay, both two are attracted by the magnets because they are made up of iron. Okay, magnetic and non-magnetic materials. Okay, children, let's divide the materials into two, the magnetic and non-magnetic materials. What are magnetic materials? The materials which get attracted towards a magnet are called as magnetic material. And what is non-magnetic material? The material which are not attracted towards a magnet are called as non-magnetic materials. The examples of magnetic materials are iron, steel, nickel, cobalt, etc. All contains iron. That is why they are magnetic materials. And what are non-magnetic materials? Examples. You can see the materials. Okay, except iron. What are they? Wood, stainless steel, plastics, rubber, etc. are non-magnetic. Objects made of iron, steel, nickel and cobalt are attracted by magnets. So out of this you can identify which and all will be attracted by magnets. Okay, in the first case it is made up of plastic. Will they attract? No, which does not contains iron, steel or any other metal. So which does not attract. And the second case you can see that a needle and a safety pin. Okay, in both cases you can see the presence of iron, so it is a magnetic material which will be attracted by magnet. In the case of third, you can see it is leather which will not attract. In this case, which is a plastic which does not contain any other iron particles, so that also do not attract. Okay, so after that, in this case, will they attract? That also never attract, which is made up of plastic. Stainless steel spoon contains iron, right? Which they contain iron? No. The stainless steel spoon which does not contain iron, so that also not attracted by magnet. Okay, and the next case you can see it is strictly a glass does not attract. This is not attract, and finally you can see iron nail which is attracted by magnet. Okay, what is magnet? A magnet is an object that has a property of attracting metal like iron, steel, nickel and cobalt. They are known as magnet. Okay, I hope you got the definition of magnet, which will be attracted by those metals. If that ability is there, that can be act as a magnet. Okay, now let's learn about the interesting factor, the types of magnets. Okay, what are the types of magnets? You can see the applications of magnets everywhere, right? Okay, so now let's study in detail what are the types. The natural magnets, which are magnetite, iron ore. The ore of iron is the naturally obtained magnet called magnetite. And what are artificial magnets, which have been created by man artificially? Example, bar magnet, horseshoe magnet, cylindrical magnet, etc. Okay. Okay, this is a bar magnet. You can see it is a bar magnet over here. The next type of magnet that you can see, and very next, that is cylindrical magnet. Okay, and this is horseshoe magnet, and finally ball ended magnet, and this is for the ring magnet also. You can see these are the type of magnet. The same textbook activity I can show here. Take a plastic or a paper cup, okay, a paper cup, and fix it on a stand with the help of a clamp. This is the stand. Okay, that paper cup should be fixed with the help of a clamp. Place a magnet inside the cup and cover it with a paper. Okay, inside you keep a magnet and cover it with a paper so that the magnet is not visible. When a outside person look, that person cannot see that the magnet is there inside. And attach a thread to a clip to made of iron. Okay, this is a clip which is made up of iron, and the end of the clip is fixed with the base of the stand. Fix the other end of the thread at the base of the stand. Okay, so after that you can observe the clip is raised in air without support like a kite. Why? Because inside the paper cup there is a magnet which is attracted by the iron. Okay. In order to understand whether a soil sample is magnetic or not, rub a magnet in the sand or soil. Through such an activity, we can find out whether the soil or sand from a given place contains particles that have an iron. If the soil sample contains iron fillings or iron particle, you can see which will be attracted by this magnet. Okay, the two ends of the magnet will be attracted by the sample. Okay, you can collect different samples. Now you will study the poles of magnet in detail. Okay. A magnet has two poles. The one is north pole and the next pole is south pole. A north pole is represented by the capital letter N. You can see in the bar magnet it is the north pole. Okay, and the south pole you can see which is represented by S. Okay, that can see in the next side. Okay. Students, look at here. This is the magnet. The same side you can see. When I am keeping the same side together, you can see it get repels. Okay. The two sides of the magnet, when I am trying to attract each other, that will be repelled. Okay. And if I am keeping the opposite side together, look at here. When I am keeping the opposite side together means it will be attracted. Okay. And what you understand, the same side repels and the opposite side attracts. North and north pole repels, south and south pole repels. Only the north and south pole will be attracts. Okay. Okay, this is a U-shaped magnet. Okay, and if I am keeping the opposite side together, it will be attracted. Like, look at here. If I am keeping the opposite side, it gets attracted. What happens if I am keeping the same side? If I am keeping the same side together means it will be repelled. It will be repelled. Okay, the same side will be repelled because these two sides is same. Okay, that will be repelled. Okay. Okay, now our task is to identify which one is the north pole and which one is the south pole. In order to understand this, you can see an activity here. Take a bar magnet. Okay, put a mark on one end of its identification. Okay, and this for identification, put a mark. And now tie a thread at the middle of the magnet. okay, that you may suspend it in it from a wooden stand. What you have to do, keep a thread at the middle of the magnet. Make sure that the magnet can rotate freely. It should be rotated freely. Only in the center part you should tie with a thread. Rotate the magnet in different direction and note the final direction in which it comes to rest. Okay children, by the time you tie the thread on the middle of the magnet, you can see finally what happens. You will find that the magnet always comes to rest in the same direction. So that is always pointed towards north and south direction. Okay. Like same way, you can find out the rough direction towards east. Okay. Use the direction of the rising sun in the morning. You can find out the direction. If you stand facing east, we all know that sun rises at east, right? If you stand facing east, to your left will be north. Not the point. If you stand facing east, your left will be the north. Once you get the north direction, automatically you will get the rest of the direction. Okay. If it is north means that will be east, opposite of north will be south, and the next will be west. Using this, you can figure out which end of the magnet is pointing to the north and which points towards the south. This is a simple activity you can do. Okay, this is the north-south direction of magnet. Okay, but like same way also you can identify the north pole and south pole. Once you get the east means the opposite will be west, and the north and south. Your left hand will be north, your right hand will be south. Okay, the same direction of magnet. Okay, you can identify the direction north, south and east by doing the same activity. Okay. Okay, the end of the magnet that points towards north is called its north seeking end, or the north pole of the magnet, not the point. Okay, the end of the magnet that point towards north is the north seeking end, and the other end that points towards the south is called south seeking end, or the south pole of the magnet. Okay, all magnets have two poles, whatever their shape may be. Okay, usually north and south poles are marked on the magnets. Just now I have shown the activity. You can see which will be marked on the magnet. Okay.